Hi guys, welcome to my YouTube channel Know About Embedded System. In this video, I'm going to explain you how to configure LCD with a microcontroller, and later I'll also show you how to develop the code for LCD. Without further delay, let us start videos. Before starting, if you have not subscribed my channel, please subscribe and get notified and also motivate us to create videos like this. So let us start the video without further delay. LCD, liquid crystal display. So what is this LCD? LCD, the full form I have already kept it here, liquid crystal display, and why it is used. The liquid crystal display or LCD is used to display output. Basically, LCD is an output device. LCD is basically output device, and LCD is used to display all types of alphanumerical and special characters. You can see the first point here. LCD is used to display your output, whatever data it can be numbers, can be character, or it can be your special characters and customized characters. So basically LCD is an output device and it is used to display all your embedded system parameters on the LCD. Okay, so LCD full form is liquid crystal display. Basically it is output device, and this LCD, you can see the third point here, LCD is a 16-pin electronic device. It will have 16 pins. I'll discuss what are those. And this LCD will come up in a 16 2 rows and 16 columns. LCD can display up to 32 characters. LCD will have two rows. This LCD currently what you are seeing on the screen, this is called basic and standard LCD. It will have 2 rows and 16 columns, and it is able to display 32 characters. And next point, if you see, it is having totally 16 pins. What are those pins? I'll explain later. And then this LCD can be operated in a two different operating mode. One is in 8-bit mode and one it is in 4-bit mode. You can transmit data in 4-bit mode as well and 8-bit mode as well. And this LCD will use ASCII values. If you want to display anything, if you want to display character A, you should send as a ASCII character. That means your LCD will understand only ASCII values, then only it is able to display. If you send directly, it will not understand. We have to send ASCII values. And LCD, in order to display anything on the LCD, we have to operate in a two different operating mode. One is command mode and one is data mode. Okay, so command mode means, you can see definition, I kept it here. What do you mean by command mode? Command mode is used to configure the LCD. There are some set of commands are there. Using those commands, we are going to configure the LCD. LCD will not directly operation. It's not able to operate directly. First, we have to configure it. First, we have to send some commands. Then only LCD will able to display. Okay, so the first operating mode is command mode, and it is used to configure the LCD. And second mode is called data mode. So what do you mean by data mode? Data mode means it is used to display the character on the LCD. So whatever data I want to display, that data has to be in ASCII format, and later we have to configure LCD in data mode. Like that, LCD can operate in 8-bit mode and 8-bit mode and 4-bit mode, and also LCD can operate in data mode and command mode. Data mode is used to display the output, and command mode is used to configure the LCD. What are those? I'll explain later. The next point here is, what are the different pin configurations? So I told you that LCD is a 16-pin electronic device. We will understand what are the different pins are there and how we can configure them. So LCD, as I told already, there are 3 sets of pins available here. The first set of pins are called as power supply pins, second set of pins are called as control pins, and third set of pins are called as data pins. Like this, LCD pins are classified into 3 categories: power supply, control, and then data pins. So what are the power supply pins? As it's a very simple definition. Power supply is nothing but the pins power supply, where we will supply the power to the LCD, is called a power supply. Here you can see these are all the power supply pins. One is VSS. VSS stands for ground. Then VDD, that is a 5 volts power supply. Then VEE, that's called contrast adjustment. And then here you can see LED positive and LED negative. There are totally 5 pins are reserved for your power supply: 5 volts VDD, ground, contrast adjustment, LED backlight display, positive and negative. So this is the first set of power pins which are available in the LCD. Second set of pins available, that is called as data pins. So data pins, directly they have given 8 pins. You can see orange color. So these pins, what you are seeing, these pins are used to transmit a data and command both. The same pins we are going to use for data transmission as well command transmission. So totally 8 pins they have given, and they have given the pin naming D0 to D7. 8 pins D0 to D7. So this is the second set of port pins, and then we have third set of port pins that is called as control pins. So we have totally 3 control pins available. One is a register select. So this is your register select, and then this is read write, and this is your enable. So there are totally 3 configuration pins they have given. One is RS, one is RW, and one is enable. RS stands for register select. So in this register selection, we can configure command mode and data mode. In the previous slide, I have explained you there are 2 modes are there. One is command mode and one is data mode. So here in this using this parameter register selection, we can configure command mode and data mode. By making RS pin to 0, you can configure as command mode, and by making RS pin to high, we can make it as data mode. Okay. And then read write, you can read and you can write both. It is possible from the LCD. When you keep read write pin as 0, it will be configured as write mode, and when you keep RW read write pin as 1, your LCD will be configured as read mode. And similar to that, enable signal, the enable signal is used to trigger the data or command. So after configuring all the information, we have to give one trigger signal. The trigger signal is nothing but high to low signal like this. So we have to give one high to low pulse. So like this, we have to give high to low pulse. That is your trigger signal. Okay, so enable signal, EN stands for enable. It is used to trigger the data or command, and we have to supply high to low signal. So these are all the pin configurations which are available in the LCD. Okay. If you have any questions, you can comment us. We'll try to answer. What are the different commands? Just now I told you what do you mean by command, right? Command means, you can see the definition in the previous slide. Command, you can see command mode, which is used to configure the LCD. So when if you want to configure LCD in a proper working condition, we have to send some commands. There are totally 16 commands available for this LCD in a different operating modes, but for standard LCD, we're going to use only 4 or 5 different commands. This is the first command, and we'll be using, and then we'll be using, this is the second one, and then we'll be using this one, and we'll be using these two. So there are totally 16 commands are there. Out of these 16, we're going to use in the regular programming, we'll be using 4 or 5 standard commands we'll be using. Explanation they have given here. Each number or each command is nothing but it's a number or a hex value. Each hex value will have its own meaning. Here you can see 0x01. What do you mean by 0x01? It is going to clear the display. Then what do you mean by 0x38? 38 means 8-bit mode, 2-line display, 5 into 7 dots. Dots nothing but pixels, right? And similar to that, if you go for 0E, here you can see 0x0E means display on, cursor on. And then finally 80. What do you mean by 0x80? Force cursor to begin from first row, and 0xC0 force cursor to begin from the second row. So like this, totally 16 commands are there. Out of 16, we will be using either 5 or 4 different commands we're going to use in our programming. If you want to do any additional configuration, we have to refer this table and we have to do the configuration. Okay, if you want to, you can see one example I'll give. If you want to turn off the display and cursor, you can see here, command number 7, display off, cursor off. If you don't want to display your cursor, you can use 08. Like this, each number is having its own meaning. We have to understand, and then we can use these commands in our programming. Okay, I hope the commands are clear. So we'll be using similar commands only, same commands in our programming. Now, so how do you interface in the, this is how we are going to interface in the coding. So I have LPC 176 microcontroller in one end, and in the other end I have LCD. 2x16 LCD. Okay, so here you can see I have in our design we have connected, you can see this part, you can see. So this part what you are seeing, these are all data pins. So 8 data pins which are connected from 0.15 to 0.22. We're using port 0 here, 0.15 to 0.22. It is connected to data pins of your LCD. Here you can see these are all my data pins. So we have data pins and we have connected already in the board. So these 0.15 to 0.22, it is already connected to D0 to D7 as a data pins. This is my first configuration. Second configuration is our P0.10 and 0.11. P0.10 and 0.11 connected to register select and enable. RS and enable. Read write, it is already grounded. So we are not using a read write in the LCD because it is already, this pin already connected to ground like this. Read write is connected to ground, saying that write operation. Okay, so in this way we have already done the interfacing in the board, and I will show you how to develop the code in the next video. Okay, now the same thing I have written here. 0.15 to 0.22 data pins connected, 0.10 RS, 0.11 enable, and read write is grounded. Okay, so I hope this circuit diagram is clear to all. So let us see how can we develop the code. If you want to develop the code, you should know the algorithm, or you should know at least the flow of the program. So it is very difficult to develop the code without knowing the flow of the code. So so that I'm going to explain here. So we're going to write 3 different functions. Without functions also you can write, no problem. So we are going to write 3 different functions. The first function will be LCD configuration. So I'm going to write like this, LCD config function. I'm going to write, this is my first function. Under this LCD configuration function, I have to do all my basic configurations. Configure the LCD port pins which are 0.10, 11, 0.15 to 22 as an output port. So this is my first step I have to do, configure my LCD port pins, that is 0.10, 11, 15 to 22 as an output port. And then we have to send different commands. You can see whatever we have seen in the previous slide, the same thing I'm keeping here. 38, 0E, 01 and 80. So these are all the different commands we are going to use in the coding part. Use these commands to configure your LCD. Right? So you can see 2-line display, 8-bit. Right? So this is my first function I'll be writing, where I'm going to configure my LCD as a port pins, LCD port pins as an output port, and send mandatory commands. So this is my first part of the coding. Second part of the coding, I need to send the commands. So second part of the coding will be LCD command transmission. I'm going to develop a function like this, LCD command transmission. So in the LCD command transmission, I need to follow some of the steps here. You can see the first step to send the command is I have to clear the data lines. Clear the data lines and then load data or command on the data lines. If you're working with the command, load the command in the on the lines, data lines, that is 0.15 to 0.22, and then make RS is equal to 0 for commands. Since I'm working with the command, you have to make it as 0, and then read write bit is 0, and give one high to low trigger. So make enable is equal to 1, give a delay, and then enable, make it enable to 0. So this is how I'm going to send the command, and you should know these steps to do the programming. Okay, then the final one is the third one, that is command transmission. Sorry, data transmission, LCD underscore data transmission. So in this data transmission, it is similar to command transmission only. Everything is same, only with a small change. The first step, again same, clear the data lines, then load the data or command on data lines, and then make RS is equal to 1. So this time, please make a note of this point here. For command, we will be transmitting RS is equal to 0. For data, we will make RS is equal to 1. So please do remember here, For command, rs is equal to 0. For data, rs is equal to 1. Okay, then rest of the procedure, it is same only. There is no difference. So like this, we're going to write three different functions. Using these three functions, we are going to configure LCD, we are going to send commands, and we're going to send data. And later, finally, we will check output in the LCD screen, on the LCD screen. Okay, so I hope this video is clear to all. So this is the theory part of our LCD, and in the next video, I'll come up with the programming and I will show you output on the board. So please subscribe my channel and click on bell icon, and I'll come up with the next video.